Okay, today's video will be about density. Density is a physical property of matter. So just like magnetism or luster or conductivity, density is a physical property. That means you can test it of a substance without changing what the substance is. So density is just like those other ones we talked about, it's a physical property. Density describes how tightly packed the atoms in a substance are. So I have three examples here. This square represents low density. As you can see, there's a certain size area, and there's only 1, 2, 3, 4, 5, 6. There's only 7 atoms in this space. So they're kind of free, they're not bunched up together, there's not very much, there aren't very many atoms in this space. This one is medium density, and there are several more atoms in this space. And they're a little bit more tightly packed than in this one, but they still have some room to move around, and they're not right up against each other. But there's definitely more atoms than in this one. And this last one is high density. So as you can see, there are lots and lots and lots and lots of atoms in that same space. So these atoms are very tightly packed together, they can't move around very much, and there's just a lot of atoms for the space. So low density, medium, and high. Okay, so how do we find density? To find the density of something, you need to have the mass and the volume of your substance. And we talked about mass and volume in a previous video, but I want to review it so you remember. Mass is measured in grams, and you find it by using a triple beam balance. And we'll do that in class. It tells us how much matter is in something. So in the previous board, the mass was the number of atoms. How many atoms are in your substance, how much matter is in there. And then volume is measured in cubic meters, or sometimes you see it written this way, M with a little 3. And you find it for a rectangular or square-shaped object by multiplying the length times the width times the height. So you need all 3 measurements, and that's if it's rectangle or square-shaped. If it's circular or uneven, we'll talk about that in our next video. So you multiply length times width times height, and it tells us how much space an object takes up. So in the previous board, the 3 squares would be our volume, because that's how much space our object took up. So let's do an example here. We have a length of 2 meters, a width of 3 meters, and a height of 2 meters. And we want to see what is our volume. So first I'm going to take my length times my width, so 2 times 3 equals 6. And then I'm going to take my 6 times the height. So 6 times 2 equals 12. So remember, I'm not done yet because I don't have a label. And the label for volume, in this case, since it's all meters, is going to be meters with the little 3. So our volume for this object, 2 times 3 times 2, is 12 cubic meters. Okay. So once you have your mass that you found on your triple beam balance and your volume, which you measured with a ruler and then you multiplied, then you can find the density. I love density. I think it's one of my favorite calculations in science because there are a lot of tricks to help you remember how to do it. So to find density, you divide your mass by the volume. So density equals mass divided by volume. Remember, when you have a number on top of another number like this, it means you're dividing, kind of like a fraction. So this is 1 over 4, you'd be dividing 1 divided by 4. So the line is your division. But with density, there's a really cool trick. I love this. Density equals the broken heart. And that's because if you draw a heart and draw a line through the middle, it looks like M over V, mass divided by volume. So if you use the broken heart, mass divided by volume, it's really easy to remember the formula for density. So I want to walk through some division review with you guys. When you're dividing, the number on top up here on top always, always goes inside. Always. So, if your number's on top, like the M here, it goes inside your division sign. The number on bottom always, always stays outside. So your number on top goes inside, and your number on bottom goes on the outside. I have a trick for that too. So if you think of your numbers like a cowboy and a horse. The cowboy is always on top. The cowboy rides the horse. The cowboy's on top, the horse is on the bottom. So if you think of your fraction like cowboy riding the horse. When you draw your division sign, the cowboy goes inside the house and the horse stays outside. It's cheesy, I know, I love it. So cowboy stays on top, horse is on the bottom, cowboy goes inside the house, the horse stays outside. So for mass and volume, for our density formula, mass is on top, mass is our cowboy, and goes inside the house, and the volume is our horse, and he stays outside. So it doesn't matter what numbers you have here. This could be 1,000,000, and this could be 2. This could be 0.00002, and this could be 30,000. Doesn't matter. This number always goes inside your division sign, your division house. Okay? And we'll do some examples of that. All right, so let's do an example. Mass equals 20 grams. We put that on our triple beam balance and figured out the mass. And the volume equals 5 cubic centimeters. So it's kind of small because we're measuring in centimeters. So what's our density? So, first of all, what's our formula for density? Mass divided by volume. So, density equals mass divided by volume. So here, we're going to put a question mark because we don't know the density, equals, our mass is 20 grams, and our volume is 5 cubic centimeters. So now I'm going to set up my division house. 20 is my cowboy, because he's riding on top. So 20 goes inside, and 5 is our horse, he's on the bottom, so he's going to stay outside. So 20 inside our division house, he's cowboy, and 5 is the horse, so he stays outside. When you figure density on your scratch paper or on the quiz or on test, I want you to set it up both ways. I want you to set it up with the formula, you put the question mark for the information you're missing, so you're missing density here, you put the question mark, and then I want you to set up the fraction, the formula, like this. I also want you to set up your division house so you can make sure you have your numbers in the right spot. Okay. So now we're going to divide. It's pretty easy. 5 goes into 20 4 times. Okay, so our answer up there is 4. Are we done? No, because we don't have a label anywhere. The label for mass, or excuse me, for density, is always your mass label / your volume label. So your label always has 2 parts for density. And the way you find this is if you set up your formula like this, you circle your labels and you read them from top to bottom. So I'll show you how to do this. So the label for our example here is going to be grams / cubic centimeters. So it's 4G / cm3. Because your label for density is always your mass label / your volume label. So G / cm3. And our number was 4. So our answer for this question is our density is 4 grams per, line is per, cubic centimeter. So make sure you set up your division correctly. Number on top is our cowboy. Cowboy goes inside the house. And that you circle your labels and read them from top to bottom. This is our answer. If you just have 4, that's not correct. Okay, let's do one more example. So here we have a mass of 5 grams. You have a volume of 10 cubic meters. And we're wondering what the density of this substance is. So remember, your formula equals density equals the broken heart or mass over volume. So here our mass is 5 grams. Then we make our division line over, and our volume is 10 cubic meters. Remember, I know which place these go into because I use the formula. Mass goes on top, so I put the 5 grams on top, and volume goes on bottom, so I put the 10 cubic meters on the bottom. So now I'm going to make my division house. And remember, the number on top is our cowboy, and the cowboy always goes inside. So even though 10 is the bigger number, 10 does not go inside. The number on top always goes inside. So our number inside is going to be 5, and then our 10 stays outside. So here's where things might get tricky. How can 10 go into 5? We're going to have to make a decimal. So you add a decimal after 5, and you add a 0. But you also add your dot up there. So your dot has to go in 2 spots, and then you add your 0. So now 10 goes into 50 5 times, and so you write your 5 right there. So if the number on the inside is smaller, you have to add a decimal and add a 0, and add a decimal on both sides to make it even. Okay. Then we also need to make sure we have our label, because 0.5 is not an answer. It's going to be incorrect if we just put 0.5. So remember, we circle our labels, and we read them from top to bottom. So our label is G/cubic meters. So G/M3. So our answer for this question is 0.5 G/M3. The really important point on this question is that the bigger number doesn't go inside. It's the number on top. Your cowboy always goes inside the house, and your horse always stays outside.